Hello, everyone. Welcome to our webinar. It's about 12 o'clock West Coast time here. We have an exciting webinar on heat pump water heaters, cost-effective carbon action. We're so excited to be here with you today talking about this all-important topic. We'll be looking at why heat pump water heaters are insanely important in our to answer our climate crisis. We will be taking a field trip to look at 3 heat pump water heaters live so you can see them installed, and we'll have your questions answered. So just a quick housekeeping note, if you have any questions, feel free to share them in the Q&A button on the bottom or the chat bubble. We'll try to get to as many as we can. So we want to give a quick shout out to all the organizations making our monthly webinar series possible. We call this the Electrify Coalition. We're approaching 30 members. These are nonprofits, trade organizations, for-profit companies. A lot of folks are interested in helping move the electrification movement forward and helping educate. So we really want to say thank you to our Electrify members. And if you're representing an organization and would like to be part of this group, please feel free to email me or Brian. I will put our information in the chat box in just one second, but we welcome more organizations to help this movement go forward. A real quick plug, this is our 5th or 6th webinar that we've been doing on a monthly basis. We've had great responses. You can catch any of our previous webinars on YouTube. I'll be putting a link in the chat shortly. So please check those out, share them. A lot of great topics. We had a chef do induction cooking. We had electrification and climate justice. We went into the bird's eye view of a high performance all electric home. And then we want to give a plug for our upcoming webinar in December. It's going to be on community solar. I'll put that in the chat room shortly. A lot of exciting things to talk about that. That's going to be on December 9th. One quick plug for our member of the Electrify Coalition, Solar Oregon is having their annual meeting on December 1st. I'll put information in the chat room, all free. And they have Hunter Lovins, the founder of Rocky Mountain Institute, coming to speak. So you don't want to miss that as well. So with that, I will turn it over to Brian.
All right, so thanks everybody. So I just want to give a little preview of what we're going to be talking about today. So you know you're right in the right place. You want to stick around. I think it's good to start with just why water heaters matter in the first place, particularly from a carbon standpoint. But we'll talk a lot about why they matter from a performance standpoint. We're going to do a little bit about how they work. We won't go deep into that, but I think it's good to demystify them a little bit. And hopefully by the end of this whole session, you'll have a little more comfort with them if they seem new to you now. We'll talk about how they reduce emissions and lower bills. There's really great information there. We're going to spend a little bit of time on tankless water heaters because I think a lot of people think of them as the benchmark for environmental or efficiency. And, I think we can set the story straight there. And then we're going to talk a lot about just the more practical things about how you get them installed, where they go, how they fit into your life and your home. And we have some of our guests here that we're going to introduce in a minute are going to be really helpful with that. Megan and Neil, who we'll introduce in just a moment. And then we're going to wrap up with just a little bit of information about all the great incentives that are available right now, because there's tons of really good promos that you should be aware of. And we'll also talk a little bit about, how to find somebody trusted to put one in. And then we'll end a little bit with a really cool story that has to do with heat pump water heaters that we call the Electrify Everyone Fund. Some of you may be familiar with that, but it's a great program we've set up for low-income households to get access to this amazing technology. So let's just start big picture for a minute. And let's take it from an emissions standpoint here. And this is Oregon information. It's going to be very similar in different states. It'll vary slightly. But in general, when you aggregate the energy that is used by all these different segments of our economy, agriculture, industry, transportation, and then basically buildings that are residential and commercial buildings, and you aggregate the natural gas and electricity that's used in those places and the emissions as a result, you'll see that our buildings here in Oregon amount for about 32% of our overall carbon emissions. So it's not insignificant. Transportation is the biggest, but buildings is the second biggest segment. And then if you look specifically at homes in Oregon, you'll see, and again, this is something that's going to be very similar from state to state. Water heating accounts for about 30% of the energy that's used in a home today. So it's a big thing. I mean, space heating and cooling is slightly bigger, and we're going to address that in later webinars, but today we're going to focus on water heating. And so if you aggregate all that data up, you know, there's basically 1.4 million single family homes in Oregon. And I kind of tend to focus on single family homes. You know, multifamily is a whole nother topic, and there's really interesting things going there. The solutions sometimes are slightly different, but we're going to talk mostly about single family homes here. 1.4 million of them in Oregon, and they're about 60-40 natural gas to electric in terms of how they heat their water. You aggregate those emissions up, it comes to about 2.7 million tons. So that's equivalent to about 450,000 automobiles. So it's not insignificant, you know, what we're talking about. It's one of those things that's sort of invisible to us a little bit. It's, you know, those things off in the basement or something. You don't see any smoke coming out of it or anything like that, but it's generating tons and tons of emissions every year, which we'll go into a little bit more detail. But the solution, which is exciting, and it's, you know, in general, the solution to a lot of these problems, pretty much all of the problems that we face from an emission standpoint in our homes, comes down to this amazing thing that's happening where we have cleaner electricity that's available and much higher efficiency of appliances. You know, LEDs I like to use as a reference case, because when we're talking about higher efficiency, we're not talking about a few percent here and there. And if you look at the, like for instance, the evolution of gas furnaces over the last 30 years, 2% efficiency gain from the minimum efficiency standard over 30 years. Not much to write home about. Whereas, you know, you look like something like these LED light bulbs, they're 10 times more efficient than incandescent ones. And, you know, the water heaters we're talking about, you're talking about multiple times more efficient, not just a few percentage here and there. And when you couple that with this phenomenon that's happening all over the country around clean energy being a bigger part of our electricity mix, and the emissions going down from electricity. In fact, there's been some really good news from Oregon just recently. Boardman, PG operated the Boardman coal-powered electric plant in Eastern Oregon until it shut just a few weeks ago permanently. It was the last coal-fired power plant in Oregon. We still get some coal generation from out of the state, but we no longer have any coal-fired power plants in Oregon. And also PGE just this morning announced that their goal is to get to 100% renewable energy, net zero as an organization, including all their buildings, their automobiles, and the electricity they generate for all of us, net zero by 2040, which is a significant acceleration of their timeline. They were initially trying to do that by 2050, so 10 years faster, and they're trying to get to 80% below what our benchmarks are from 2010, I believe, by 2030. So this chart you're seeing of, you know, emissions going down from electricity is, I think it's going to get steeper because a lot of these people like PGE are doing the right thing. So it's exciting. Combination of efficiency and clean energy. And that's why electric heat pumps are such a great story, because they take advantage of clean energy that's available, and we'll talk about that, but they are just massively more efficient than any other form of water heating. So I think we should spend a little bit of time about heat pumps, because heat pumps seem like one of these magical things. And how is it that something can deliver more useful energy than it absorbs? You know, it seems like it's impossible, you know, because these things have efficiencies of 300% or more in some cases. How is that even possible? Well, first of all, I think it's important for us all to realize that while heat pumps are a little bit hard to explain to people, and I'll do my best here without getting too deep into the geeky stuff, but there's something we're really familiar with. I mean, you know, all of us have had refrigerators and air conditioners in our lives for, you know, decades. And a refrigerator, I think, is the best example to sort of demystify heat pumps a little bit. What a refrigerator is doing, you know, so it's an insulated box, and the heat pump is literally moving the heat from inside of the box to the outside. So your kitchen gets slightly warmer, and inside the refrigerator gets dramatically cooler. So that's why they call them pumping, heat pumps, because they're moving this heat from one place to another. So it's a very efficient technology that just moves the heat. It doesn't create new heat or create cool, which is not possible, I don't believe. But you can get this incredible efficiency because your kitchen gets slightly warmer. I mean, if you ever put your hand behind the refrigerator, you'll notice it's warm back there. So your refrigerator, your kitchen's gonna get maybe a partial degree warmer, but inside the box, it gets dramatically cooler. And air conditioners do the same thing in reverse. Or, well, they do the same thing where they're pumping the heat from inside your home to outside your home. And a heat pump water heater is absorbing the heat from around it and concentrating that heat into the water inside the tank. So most heat pump water heaters are configured in a similar way. This is the Rheem model, but if you look at other models, they're very similar. They have a evaporator and compressor up on the top. And basically what that's doing is it's sucking air in, like in this case, the Rheem model is sucking air in here and blowing it out over here. And it blows it across these coils, which warms up the refrigerant that's at a highly compressed state inside this machine. And then this combination of compressing the fluid and then decompressing it enables you to heat this fluid up a little bit and then release that fluid into the water that's in the tank where these coils are surrounded by it. So without getting into all the physics, it's a slightly magical process that absorbs heat from the environment and then concentrates it into the water. So we'll talk a little bit about what the impact of that is, because that has an effect on where you put this. You wouldn't want this in your living room because it will cool your living room down, which is why we say it has to go in unconditioned spaces or be vented to the outside. And we'll talk about both those things a little bit in the future, in the moment here. But the thing to remember is it's absorbing heat from around it and concentrating that into the water. And what really matters is that the effect that it has on what we experience in our homes. And, obviously hot water, it's kind of hot water. It doesn't really matter how you warm it. And it's as comfortable hot shower as any you're going to take. But what really is awesome is how much more cost effective it is. So if you have an electric resistance water heater, for here in Oregon, for about $10, you're going to get 3 really good hot showers, like 10-minute hot showers, which, that's, I know some of you might think that's luxurious, but if you have teenagers, you'll know that's nothing. So 3 hot showers for $10. And if you have a natural gas, kind of a typical natural gas water heater, you'll get 5 or 6, depending on the efficiency of your unit and how old it is, et cetera. If you've got a tankless version, you're going to get more, slightly more. It's not dramatic, but you'll get 6 or 7 instead of 5 or 6, something like that. But if you have a heat pump, you're going to get 10 or maybe more. And again, this will depend a little bit on what mode you put it on. We're going to talk about that because they have different operation modes. But in heat pump mode, you're going to get 10 hot showers for $10. So it's a dramatic improvement in cost effectiveness. And if you look at that, another way of looking at it is we like to just use the Energy Star data because the government tests every new water heater through a similar protocol. So you get this real apples to apples comparison. And at the very best resistance water heater you're going to get, it'll come with a little label on it from Energy Star that says that it's going to take $419 a year to operate that thing. And it's going to cost you, they're cheap. These are some of the cheapest technology for water heating that are out there. A good natural gas, just a decent one, is going to cost you less. So it will be cheaper than the electric resistance one. The very best natural gas one's going to be slightly cheaper, maybe $200 a year to operate. But of course, now you're looking at a price tag of several $1,000s to install that thing. Tankless ones are, again, incrementally better. But the heat pumps just blow this away because now you're talking about $100 roughly a year for hot water. And of course, this is all going to depend on how much hot water you use and stuff. So I kind of tend to think of these as, the miles per gallon stickers that come on automobiles. You might never actually get that, but it's a good way of comparing one automobile to another. This is a similar kind of thing. And with the prices coming down on heat pumps, particularly with incentives, this is right from Home Depot right now, $6.99. It doesn't even take into account the other incentives that are available. You can see they're very cost competitive. If you look at it from a carbon standpoint, though, it's even more dramatic. The resistance one is about 1.5 tons here in Oregon. Gas is going to be over 2. And just a note, because a lot of you probably don't really geek out on this stuff, but if there's anybody out there who does calculations on carbon, these numbers for electricity and gas here use the complete life cycle of the gas from extraction all the way to combustion. It's not just the combustion value. This comes from the Oregon DEQ, so it's very solid data. But so that's why these numbers are bigger than you might see if you looked at somebody else who's done this calculation, just use the emissions, the combustion value. But it's important to consider the whole life cycle, and same for electricity. So with the best natural gas, again, it's going to be better, tankless, slightly better. But check this out, from a heat pump, you're talking about 75% less carbon emissions from these things. And a lot of you will know this, but we want to always remind people that if you charge that thing with renewable energy, which is very easy to do today, it'll be 0 emissions. You cannot do that with natural gas, but you can sign up for a green power plan from PGE or Pacific Power here. They're available all over the country. You could put rooftop solar on your house if that makes sense for you. We're big fans of that. If not, community solar is coming in more and more places. We're going to be talking about that at later webinars here in Oregon. It's super exciting to get, and these are 3 different ways to get renewable energy to your home, and that'll make carbon emissions for your awesome water heater 0. Okay, just a moment on tankless here, because a lot of people think about tankless as the gold standard for efficiency, and it was. I think for a long time, this was the best we could do because it was the most efficient device that was out there. So we have to give them their moment in the sun. But the truth is they cannot compete with a heat pump on any level. And there's some really interesting information that's coming out recently. In fact, there was just an article in, Green Source News or something. I can find it for you if you're interested, or Joe, maybe you can put it in the chat, about how these devices, and it's the same for a stove. Every time you turn it on, it is going to release a tiny little bit of unburnt methane before the flame catches that methane on fire. And with a water heater, anytime you turn on your tap, like you have one of those taps that's a mixing tap, anytime you just turn it on, you're going to be pulling some hot water, even if it's just a little tiny bit, which is going to turn your tankless water heater on, which is going to spurt out a little bit of unburnt methane, which has like 80 times, or sorry, a lot more carbon sort of greenhouse gas potential than when it's burnt. So basically, when you take on and all of these into account, it reduces the efficiency from a kind of carbon standpoint even more. And these things are gas powered. They cannot be powered with renewable energy. So it's just not possible. So these things are going to be at least twice as expensive to operate as a heat pump and 4 times more carbon. So it really just can't compete. They are the standard that was. All right. I think I want to wrap it up here a little bit with reliability. Because these things are new, I think like people might have questions. Well, are they going to break? How long do they last? One good way to think about that is what the manufacturers will, warranty. And so an electric resistance is the simplest technology out there. You're going to get a lot of warranty life for these things because they're very simple machines. A lot of people would be surprised to know that your gas water heater only has warranty for 6 years. So it's half what an electric resistance one is. And a heat pump, these people are confident in the technology, and it's not just 1 or 2 companies that are making this. All the major manufacturers that make water heaters make heat pump water heaters now. So you're going to get a 10-year warranty in almost every case which shows that these people are confident in their products. All right, so we're going to talk about this in more detail in a minute as we do our little walk-arounds in our own basements and garages here. This is going to be, we haven't done this before, so it's kind of a new thing, but because these things are different, there are some things you need to know about where they go. They have to go in an unconditioned space. We're going to talk about that. Garages and basements are perfect, or maybe you have a big utility room. They typically need quite a bit of space around them because it has to take that heat from the air around it. So if you put it in a little closet, it's not going to work unless you vent it to the outside. And it takes a little bit more power than just a regular wall socket. You need 240 volts for these. There are coming 120 volt versions, but the ones that really work well are 240 volts, and they're going to take 30 amps. There's some workarounds there, but 30 amps is typical. And then they need a condensate drain, which we'll talk about. But a lot of furnaces have these, air conditioners have them. There's not, your refrigerator sometimes might have one. So it's not like rocket science, but it does take in consideration. All right, so with that, I want to introduce our two guests. They've been sitting patiently here, and I want to introduce them because I'm really excited about Neil and Megan, who have agreed to join us here today. And Neil, I'm going to let them introduce themselves a little bit, but Neil is a program manager with the Environmental Center, which is one of our Electrify coalition members, and doing some great work in Central Oregon. He's a self-described climate geek, knows a lot about a lot of different energy efficiency technologies, and really working to help reduce the carbon emissions that are coming from that part of the state. And Megan works for Green Savers. She's a home performance consultant who's got a lot of experience, which is why we wanted to have her on this program. A lot of experience with installing these kind of products and analyzing energy efficiency in homes. So she's got a really interesting background in wildlife biology, but has decided to kind of devote herself to buildings and efficiency in buildings. And so welcome, Neil and Megan. And maybe Neil, maybe let's start with you. Do you want to just give yourself a little intro here?
Yeah, thanks, Brian. I think I could add water heating geek to my list of geek traits. It's a fascinating world, and it's a space that not a lot of people pay attention to, which I think is one of the reasons why there's a lot of opportunity here. Like Brian said, I work for the Environmental Center. We're based out of Bend, Oregon, but serve the Central Oregon region. And really, my work there and with the Environmental Center is just advancing clean technologies, depending on kind of what the clean technology of the day that needs a little bit of help. And heat pump water heaters definitely fit into that category. Brian also touched on this a little bit, of why heat pump water heaters have such a big opportunity. There have been small incremental gains in different appliances, and water heating is an area where we haven't seen very much of a shift up until heat pump water heaters came onto the scene. Electric resistance, shifting from electric resistance or from gas to a heat pump water heater is that monumental shift. It's like the incandescent to the LED, which is why it's so exciting, but it takes a mindset shift as well, because we're not used to those types of fundamental shifts in appliances. We expect incremental gains. So it needs a little bit of help for adoption. So that's why we've been really invested in it. A little bit of a case study. 3 years ago, when we first started getting involved in heat pump water heaters, we did a little bit of a secret shopper scenario. I think my mom's on the call. I had her call to make it even more realistic. Calling different plumbing outfits and asking if they installed heat pump water heaters. The responses that we got 3 years ago was, do you mean tankless? I think so. I don't know about that. Basically, every plumber in Central Oregon had no clue what we were talking about. So we've definitely come a long way since then, and have some really great partners like Green Savers that are installing these. And also just the reliability of the units, the availability and pricing has really come a long way. So we're really excited about this shift, and I'm excited to show you all more and explain a little bit more about the specifics. So there's been a lot of questions that have come in the chat. Joe's been looking at them as well, but before I pass off to Megan, I want to remind everybody that when you're looking, when we go on our field trip, into our garage, basement, and closet, ask specific questions. We have people that are living with them, and we have Megan, who's an expert in both quoting them and installing them. So you have an opportunity to learn a lot about kind of what the different options are out there. So super excited to be here, and I'll pass it off to Megan.
That's great. Sorry, I just wanted to reinforce one thing you said before we pass off to Megan. I mean, this thing about the installers, and we're going to talk more about this, but it's very true. You know, you can call somebody and they'll tell you you're crazy to take your gas water heater out and put it. The contractors are not all on the same page here, so we'll talk more about why it's important to find somebody who knows what they're doing here. And Megan is exactly that kind of person. So Megan, why don't you take it away?
Thanks, Neil. Thanks, Brian. So a couple little housekeeping things. We have been considered an essential service, so we're still installing water heaters, doing what we do here at Green Savers in the greater Central Oregon area. So I'm working from our office today, which is where I'm wearing a mask, and I apologize for any background noise, which I'll try to minimize as much as possible. So yeah, I've been with Green Savers a little over 4 years now, and am our senior consultant and primary project designer. So on a day-to-day, I meet with stakeholders, most typically homeowners, to help key them into home upgrades that will ultimately conserve energy, save money, make the home more comfortable, healthy. So I do a wide array of projects, as we are a home performance contractor tackling anything associated with a home's energy. And a big one right now, and this part of this whole panel thing, are heat pump water heaters. So I'm excited for our field trip and to be able to inform you guys about some of the stuff we run into in the field as project designers and installers, common considerations, and let you know how they can be a good fit in almost all scenarios.
All right. Well, great. Thanks, Megan. And thanks for being with us today. I'm excited. I know you're going to be able to answer some of these questions because you've probably seen a lot of different situations. I think we're going to, Neil, are you ready to go here? I'm going to stop sharing my screen here and we're going to take it over to Neil, who's going to show us his water heater.
Yeah, perfect. Is my mic working?
Yeah.
Okay. Well, welcome to our garage laundry room. And the showcase of the room is really the heat pump water heater. It's cycling in the background, so you can hear kind of weird noises going on. So just a little bit of the anatomy of where this fits. We talked about there's a space requirement for this. It needs access to a large volume of air. So really, there's some areas where these can just be a total shoe-in, no-brainer, easy installation. And then other places that we'll show you through some of the other installations where it takes a little bit of work, but also is totally doable. So this is in a converted garage space. And I'll show you a couple of things that made this particular install a little bit easier. For us, we had a gas water heater here just a couple weeks ago. So this is pretty new for us. And I think along with a lot of other places, this house used to have an electric resistance water heater. But then they upgraded to a natural gas because that was the better unit at the time. One of the advantages that provided for us was it was already wired for an electric water heater. So we're able to attach that pretty easily. So you can't see it, it's kind of off screen, but we already had our electric hookup here. And they're also, if you don't know what you have, I was in a lot of homes for a different program, and a lot of people don't know what type of water heater they have. If there's a pipe coming off of the top, a vent pipe, then it is a gas water heater. So that's kind of one piece, is that electrical connection. Another different piece is the water connections to the unit. Most water heaters that aren't heat pump water heaters have their attachments up above and then flex lines running into it. So your plumber has to run your plumber is going to have to run to connect. The hot water comes out here and the cold water goes in at the bottom. So that's a little bit of a difference as well. And then one last difference is that condensate piece. Heat pumps, because there are cold coils inside, they're also pulling condensation out of the air. And so that condensate is draining this location is right next to a washer and dryer. So we had it pretty easy because we can gravity drain directly into the same drain as our washer and dryer. And there's a lot of options that contractors can point out. So you can find a way to move the condensate. It's maybe, we didn't have it plumbed in right away because I wanted to see how much it was creating. And we were generally generating somewhere between 2 and 4 cups a day. I see all the notes on insulating the pipes. You're totally right. We're just getting this installed. So yeah, especially the hot water line leading here. This is warm and should be insulated. Wanted to make things pretty visible for the demonstration today as well. Other notes, I'm gonna try to do this as smoothly as possible so people don't get nauseous. In the controls piece of this, this is something that's different than most water heaters. They're a lot smarter and there's a lot more that you can control. You can actually set a digital temperature and set a schedule. So this is something that we've done because it's in we've been able to tweak a couple of settings to make it work for our house. There's also multiple settings. So sometimes people call heat pump water heaters hybrid water heaters. And the reason why they do that is because the water heater itself has 2 different modes of heating. One is as a heat pump. So it's pulling in the ambient air here because it's unvented. And then it's exhausting colder air, colder air off the side right there. So that's kind of the main mode and the mode that we're the most excited about. But it also has the standard electric resistance coils that you'd find in any electric water heater. So what that does is it gives you the flexibility to be able to modify how you're heating depending on your usage, depending on if things fail, and also depending on the time of year, depending on what the kind of ambient air temperature is, regardless of where your unit is located. So there's different modes for the water heater. This is a Rheem model, and it has a heat pump mode. It has an all electric mode, so that just turns it into a standard electric water heater. Has a vacation mode and an energy saver mode. And this is also kind of the hybrid mode. So that's where it's paying attention and can run the heat pump and cycle on and off the resistance to get you a little bit of a quicker recharge rate. And then a high demand mode. So there's lots of different options of how you're going to run it. We both temperature and modes we have on a schedule to try to make sure that we have enough water when we need it, but then it's not cycling too much when we are spending time in this room, because we do feel the cool breeze. Although the ambient air temperature in the room isn't dropping very much, if you're in front of the unit, you definitely feel it. So I'll leave it at that for now.
Neil, I just wanted to chime in a little bit on the modes thing, because one of the reasons why that electric resistance or hybrid mode is interesting is it can affect your recharge rate. So I know with like, for instance, if you've got a lot of people in your home taking hot showers, like if you have guests that come over, or in our case, our kids come home from vacation or on vacation, a lot of people are taking showers. The hybrid mode will heat the water slightly faster, or the electric resistance mode will. So we tend to leave ours on heat pump only also, but that hybrid mode can get you faster recharge rates on hot water than the heat pump will by itself. When you say that's accurate?
Yeah, and then what was I going to say about that? Yeah, the faster recharge mode. And another note too is when it's on the hybrid mode, some people, these units are not as efficient of a heat pump as like a ductless mini split or something like that. So they do have a temperature at which they will not be able to run as a heat pump. So there's not enough heat in the air for them to pull it through. And so depending on if you have this in a garage in Central Oregon, which is a little bit cooler than the Valley, most of the time it's going to be able to do just fine with the ambient air temperature, but occasionally you might drop below the set point for the unit. And so for Reem, Megan commented in there that 39 degrees, I know it depends on the manufacturer as to how their heat pump is configured. So if you hypothetically had if you hypothetically left the garage door open, it was in an unconditioned but space like a garage, and it dropped below that temperature, then you're going to be able to use a little bit of electric resistance to fill in for those few days where it might not be able to make it just on the heat pump. Same with if you have it ducted to an outside space. And so that allows you to have the flexibility to make it work, in a lot of different scenarios. One other point to note, and I know we're going to talk about a couple of different systems, but there are opportunities and pilots with some utilities to try to do a little bit of demand response. And so you can have the unit cycle during periods of excess renewable capacity on the grid, and then you have that thermal storage inside of the tank for waiting for later. That might be a little bit too deep, but we'll go into more detail if there's more questions there. So if you have any specific questions about this install, I couldn't read them all as they were coming in, but you can put them in the chat or the Q&A section.
So Megan, I have a kind of a question for you while we're here. Some people say that it's best to oversize your tank if you have a heat pump because because that way you can have the heat pump operating for longer and then you've got more hot water to draw. What's your experience with that? I mean, 50 gallons is really common. If you've got a 50-gallon tank and that's working for you now, should you get a bigger heat pump, or what's your point of view about that?
We typically see, so kind of stepping back a little bit, and this is especially important in a place like Central Oregon, where our supply water is just very cold, just comes out of the ground quite cold, on average about 45 degrees. And so a big misconception, I think, with storage tank water heaters is that, the size of the tank is more important than its recovery rate, which we express as a first hour delivery rate, which for most homeowners and consumers is the, I think, more meaningful term, because it does express how many showers you get back to back. Can you do a load of wash after you take those showers? So I encourage folks to look at that first hour delivery weight and consider, their appliances. Do you have a low flow shower head? How long are your showers? That kind of thing when making those decisions. But we very rarely are oversizing or upsizing a unit with that education, that understanding, and the fact that these units can produce quite a bit of hot water. So more than meets most homeowners' needs, sticking with if they've got a 50-gallon hybrid heat pump unit is typically what we're going with. I have seen some chats come in about 2 units, which, there can be a variety of different 2-unit setups. Oftentimes we'll see what's called a daisy chain, where you'll have kind of one water heater dumping into another water heater. And that was often done to have enough capacity to keep up with, larger families or soaking tubs and things like that. And so a great way to eliminate some of the standby loss, having 100 gallons of hot water ready to go 24/7, 365, is to, get down to one potentially smaller unit that can still keep up with your shower needs, your domestic hot water needs in general. Does that help answer, Brian?
Yeah, absolutely.
Brian, I'm looking at time a little bit. I think we might want to move to your.
Okay, well, I'll show you our setup here. So our unit is a little bit older than Neil's, but very similar. You can see I'm in my basement here. This is our heat pump furnace. This is where we had a gas power vent model before that we replaced with this. So the old vents that used to go up through the ceiling and through into the chimney are here from the power vent. By the way, this is a lot quieter than the power vent unit was. I mean, when that gas power vent unit went on, you could hear it through the whole house. You can still hear it if you're down here, but it's a lot quieter. So again, sucking air in, blowing it out. We have, I don't know what else really that needs to be seen here. I will show you the condensate pump because we had to have a condensate pump put in, which again is pretty common, but Neil was able to use gravity. In our case, the condensate from here comes down into this pump down on the ground, and when it collects enough moisture, it pumps it through this pipe over to our utility sink, which is in the corner of the basement. And so basically there's one for the furnace and one for the water heater. So this is very typical. These things aren't scary. At first it sounds like, what, condensate pump? But it's really like no big deal. Megan, you've probably got tons of experience with those, right?
Yeah, they are very, very common to see. They last a long time. So that's something I do field questions on quite a bit, is the lifespan of a condensate pump. And they tend to last about as long as a water heater does. So yep, something we see commonly. Just requires a standard 15 amp outlet. Doesn't need to be a dedicated circuit or anything like that to power that pump.
Maybe one last thing I'll show before we move on to Joe, because some people might be interested in this. There's a feature that some of these come with is this leak detector. It's basically a little sensor that goes down on the floor that detects moisture. And, you know, I'm not sure that I would have like paid extra for that. It came with this model, but it's kind of a nice feature, I guess, if you ever had a big problem with your water tank. But basically it'll make an alarm sounds if it senses moisture down there. So speaking of moisture though, oh, sorry, go ahead, Megan.
I was just going to add that for some folks, they're attracted to the EcoNet technology on these, which does allow you to connect the water heater to your phone via an application. So we see that a lot in vacation rentals where folks, you know guests won't be there for a period of 5 or 6 days, so they can remotely toggle between modes doing that. So it's an add-on feature, but if folks are interested in that, it's available.
Yep. The other thing I was going to say about moisture is, you know, we have our basement here is, you know, it's unfinished. As you can see, it's pretty dry, but this definitely dehumidifies the space, which means that you get less, you know, mildew and that kind of stuff that's happening down here. I don't know. Have you seen that in your experience, Megan?
I'm sorry, I was responding to a chat. What was the question?
I was just saying that our experience is that it dehumidifies the space down here pretty significantly. We see less mildew and that kind of stuff than we used to.
That's absolutely correct. An install will both cool and slightly dry the area of install if it's not ducted. So a free dehumidifier in some capacities.
Yeah, and so on the cooling thing, so, you know, it's always cool in your basement. It's typically going to be like around 55 to 60 degrees in a underground basement like this all year round because of it's got earth all around it. I would say it's probably a couple degrees cooler down here than it was, but it's not like you really notice it. You know, I mean, I think I've had a thermometer, I could tell, but. Okay, Joe, should we keep us moving? Do you want to show your setup?
Yep, absolutely. Everyone, welcome to my house here. I'll be really quick since we got a little bit over, but this is my beautiful coat closet. My wife was complaining that we're showing the ugliest part of our house, but we wanted to show this application for some folks. We're putting in the chat room. You know, I've got a tiny space. I can't, you know, it's not an unconditioned space. So then I can't use a heat pump water heater. I was in the same boat. We turned our garage into an ADU, an apartment. And so we don't have a garage anymore. So we had an old gas water heater in our house, and it was time to go. It was about 18 years old, and it was in our coat closet. And so we said, well, how can we put it in here? Well, we ducted our heat pump water heater. So it's really a similar heat pump water heater to Brian and Neil's, but as you can see, it's got this duct over here that pulls air from the attic, and it sits above the insulation, just pulls the air right from the attic and pulls that heat, and then heats the water, as we were talking about, and exhausts cold air out of the attic. Somebody put in the chat, well, you know, can you use that free cold air in the summer? Could I just attach this duct? We've tried that before. It wasn't a ton of cold air. You could totally do it, but a lot of times it was running in the morning when you didn't really need it as much. But that's totally an option. We just leave ours ducted here. We liked this so much that we decided to, in our apartment unit where we had another gas water heater, we decided to install the same heat pump water heater there, and that one runs our radiant floor system for 400 square feet as well. And the last thing I wanted to show that people were nervous about, I was nervous about because this is right in my house, is how much noise do they make? And it's really, it's like a refrigerator or less. And I'm gonna just show you real quick. I'm gonna turn up the temperature on my water heater and turn it on. And I'm gonna hopefully not make you too dizzy. And let's see if we can hear the very quiet. It's really a non-issue. I don't know if you can hear anything at all. A little fan sound and, you know, really next to nothing. So yeah, I just want to show you this application as well. So I'm gonna remove my pin, and I guess before I go back to my desk, any questions on this application, or should we move on to Neil? Why don't we move on?
We can hop back to the presentation if you want to get that back up, Brian, and I can try to go through these next sections a little bit quicker. So thanks for joining us on that field trip and little experiment of going rogue and going out of our office spaces. So I wanted to talk about incentives. I know that this audience is not just in one area. So these units, although they're more expensive at a retail price, there are a lot of incentives because these have such a big opportunity for savings. So I generally like to think that there's 3 different buckets you need to check before evaluating or before kind of getting an idea of how much that unit's going to cost. The first one is a lot of these incentives have been moved midstream, which means that they're actually discounted at the point of purchase when you're buying them directly. That's also true for installers. So this is a move that a lot of utilities have done to try to make it easier, and so you don't have to apply for an incentive afterwards. It's already just pre-applied. So an example of that is right now as a Energy Trust customer. So that's a PGE or Pacific Power customer in Oregon. You can get these incentives applied off of the purchase price, and you can actually order them online. That's how we got ours, and we were able to order it online and have it delivered for $399, which is incredible. So there's midstream incentives. That's one of the buckets.
Just by the way, this link to the ETO GP, this is General Pacific Conservation. It's on our website too. If you want to find it under contractors and products, you'll see it there. But yeah, these are amazing prices, $399.
Yeah, it's ridiculous. These are, I call them ridiculous deals. So another chunk of spots that you want to check is that sometimes there's some seasonal installer promotions as well. So checking with folks that are really excited to do this work. Megan from Green Savers, they have a program running right now, as well as Great Northwest Installations in the Portland area, where they're discounting the installation costs as well. So this can, if you're having it installed, can really, I mean, we're talking about significant improvements to the cost effectiveness when the install costs are as low as they are. So this is a really important time to check it out. If you're interested in this right now, do this outreach soon, because a lot of these incentives are here until the end of the year. Next slide.
I just wanted to give a plug for Green Savers and Great Northwest too, because, you know, like we were saying earlier, you know, you can call up your local plumber and he'll tell you you're crazy to do this, blah, blah, blah. And they're technically capable of doing it, but they might not be excited about it. It's something that's changing, but at the moment, I think it's fair to say that not all plumbers are going to be excited about doing this. So we like to just say, well, why work with someone who's not excited about it? Work with these people. Between Green Savers and Great Northwest, I would estimate they put in more heat pump water heaters in Oregon than probably most of the other contractors combined. And so they've got a lot of experience with this, and they offer great pricing. Why would you want to work with anybody else?
Yeah, and I think that's a good setting the expectation. A lot of plumbers, just to give some feedback, like if I was calling a plumber and they told me I was crazy, I'm not a plumber. It's important to recognize where they're coming from. A lot of plumbers with some of the early heat pump water heaters a couple generations ago were told that they were great, but then weren't followed up with the kind of service and reliability that they were wanting. And so a lot of plumbers have been slow to jump back on to a new technology, but these have proven themselves time and again. So once people kind of figure it out and figure out that this is the best water heating option like Green Savers and Great Northwest Installations, then they're happy and excited to do them and service them. So yeah, great options there. So a little bit more about utilities. I can't stress enough how many incentives are out there for these units, both midstream as well as other incentives. So just some Oregon specific pieces. Eugene Water and Electric Board, they have the same deal that we pointed out with the online order of $3.99, but they're $175, even a better deal for people in EWEB territory. Also, if you're a co-op member, so a member of a electric cooperative, there's options to be able to get these units either through a plumbing distributor or for a hardware store, and then there are incentives on top of there through more of a traditional rebate process. So I know for our 2 local co-ops, there's a $500 and $600 rebate above and beyond the $500 and $600 rebate above and beyond the midstream incentives. So these are the crazy deals, and this is really just highlighting that there's a lot of value in these, and that's why everyone is trying to push some money into trying to increase the adoption here. Also, there can be income qualified discounts, low or no interest financing through your utility, and different incentives depending on rentals. And one other note, this is an electrification webinar. It is important to check the rules of the promotions, and some of the incentives with utilities don't allow for the incentive to be applied if you are switching fuel. So it's important to make sure most of these, because they've been pushed midstream, it is no longer explicitly written in the rules, but it is an important thing to make sure that you don't have an expectation that doesn't end up working out for you. But yeah, so that's utility rebates.
Yeah, this website, hotwatersolutions.org, is a good one to know about, and it may not have all the answers, but you can do a quick search with this utility rebates here, and you can scroll down and find your utility and see what they say. But I think it's always good to just contact your utility directly to see what they're offering.
Yeah, and Hot Water Solutions also has really good resources for folks that are installing the water heaters themselves. And then the other piece is the federal tax credit. So this is this tax credit is available only through the end of 2020. It's a $300 tax rebate for your primary residence or business, and this is on top of all of those other deals. So this is another reason, whether you're installing it yourself or having it done professionally, to get it done this year, is you're eligible for that additional tax rebate. I'm also going to put in a shameless plug that if you're trying to get things done by the end of the year and you have an electrician out to your house, there's also a 30% tax credit for installing EV charging infrastructure at your house. So if you have an electrician there wiring that in, you can take advantage of that tax credit that also expires at the end of the year. And so next slide, I want to kind of wrap things up a little bit in calling attention to kind of where we're at and where we can go. We've talked about some of the barriers that we have to adoption right now, some of the great benefits and the real importance of this being a strategy and moving forward and reducing the carbon in our homes. Right now in Oregon, only about 2% of Oregon water heaters are heat pump water heaters. So we have a long way to go. We've seen a big uptake in new construction. We've seen more and more contractors offering these, but we can do better. An example of another area that has done significantly better than us, in Vermont, their efficiency group, kind of like the Energy Trust in Vermont, is called BEIC. And they really looked at the problem of not seeing a high enough adoption of heat pump water heaters. They have similar cold climates and similar concerns that folks in Oregon have. And through some targeted approaches with reshifting their incentives, incentivizing contractors and distributors to encourage these types of installations and getting people comfortable with them, in a 12-month period, they went from 7% of replacements being heat pump water heaters to 60%, which is a mind-boggling success of a program. And now 66% of water heaters in Vermont are heat pump water heaters. So these are, the general message is that there's a lot of room to grow in this area, but it's here and I think we're ready for it. So I'm going to pass it off to Joe to explain a great project of being able to make these electrification benefits available for low-income customers and just a broader audience.
Cool. And I'll be super quick so we can get to some questions. Electrify Now, some of you have seen when you've been signing up for our webinars. We're partnering with Community Energy Project here in Portland to help. We've created this Electrify Everyone Fund. So folks who are trying to offset, quote unquote, it's not an official offset program, but are looking to reduce their carbon emissions can donate $20. And that avoids a 1 ton of CO2. And what that $20 goes to, and as some of you who donated signing up for the webinar, is to installing heat pump water heaters in income qualified households. And not just installing heat pump water heaters, but installing them where gas water heaters were. There's funding to make the conversion from electric to heat pump, but from gas to heat pump, there's no funding because of those fuel switching rules. So we'll put a link in the chat to go to Electrify Everyone Fund. It's an amazing program. We've just installed our first 5 hot water heaters. And to date, just through our webinars, we've raised $550. At $750, we can install a water heater. So we're so excited. We're getting close to installing our first just from these webinars. And we've had enough folks and companies donate to install possibly over 100 water heaters to date. So we want to really grow this program. And so we'll put the information in the chat. And with that, we've got a lot of questions for our panelists here, and we're getting close on the top of the hour. So we may go a little bit extra. If you need to sign off, we'll send the YouTube recording. If Megan and Neil can stay on an extra 5 minutes or so, we can try to get to as many questions as possible. I've got a lot here listed. One, I'll read. How much of a concern is dust for a heat pump water heater that is outside? Someone in Arizona, Megan.
Dust isn't typically too big of a concern. The units do have a filter that you will need to clean. They're cleanable. You don't need to go, run to a store to buy them. You can rinse them under a kitchen sink and dry them out, or use a hose vacuum to clean them out. And so that's designed to protect the heat pump system, the mechanics of that. And so as long as you're cleaning those filters regularly, I'd say about twice a year, maybe 3 times if it is a really dusty or dandery location, you should be good to go.
Great. One other question, please discuss the refrigerant choices, fluorinated carbon versus CO2.
Neil wants to do that one. Go, Neil.
This is a really exciting new area for heat pump water heaters. Their refrigerant management and moving to carbon-friendly refrigerants is an exciting move in the industry. We have one example of a commercial product made by a company called Sandin. And this both answers 2 questions in there. One about lower global warming potential refrigerants, because it uses CO2 as its refrigerant, and also an outside unit. So this is an outside, Sandin systems have an outside unit with a heat exchanger and then an inside storage tank. So this is a technology to definitely keep your eyes open for. They're available, and we're starting to see them in some exciting new construction projects here locally. I just saw my first one. So this is definitely a move that the industry is going to have to take, looking at broad scale climate problems, is paying attention to refrigerants. And so CO2 is a promising option out there, and Sandin is the only one that I know of in the heat pump water heater space right now, but definitely worth checking out.
Yeah, I think the other thing I would say about refrigerants, because I think it's a good call, and there are ever increasing standards for the refrigerants, which are making them less dangerous from a greenhouse gas standpoint. But I think it's also just important to know that a system that's installed properly and serviced properly is going to should have 0 refrigerant leakage. If you rip this thing out yourself and just throw it in the garbage, you're possibly going to have some refrigerant leakage, which is really bad. So I think it's important that we remember that, if we service things properly, the refrigerant leakage shouldn't be an issue. But it's always going to be better if we have refrigerants that have lower greenhouse gas potential. There was another question that I saw someone ask about panel size, and Megan, maybe I don't know if you're still with us, or maybe she had to leave. Some older homes have panels where either all the breakers are being used or they don't have enough amperage to accept a load from one of these modern devices like a furnace or a water heater. That can be a limitation.
Megan's still with us, Brian.
Oh, is she? Okay, sorry. Megan, do you want to address that?
It can be a limitation. You can get panel or service upgrades if that's required. So yeah, it's largely related to the age of your home and your panel's capacity. I would say we don't see it too often in Central Oregon. And our main barriers here with our housing stock is panel capacity and the panel already being full. So you can get around that, however.
Yeah, we had to put a little sub panel in on our house. It wasn't that big a deal, but all these things do add some expense, which is annoying. And it's, it's one of the things that's a real issue with transition. It won't, every house is different, so you might not have that problem at all, but in some cases you're going to incur some slightly higher electrical expenses to put these new devices in.
Great. A real quick question on can you be more specific on the space needed? I have an unconditioned utility room that is about 4 by 8 feet. Is that big enough? The room also includes the furnace. There are a lot of questions on how big Neil's room was, and what kind of size room should.
I believe Ream says 700 cubic feet. So you need, if it's 4 by 8, and it's 750 cubic feet. Okay, so yeah.
That room is only 250 cubic feet. So Megan can probably speak to this as well. Your options with a smaller room, each manufacturer has different recommendations, but sometimes you can use a louvered door to make it share space with another area and have it kind of particularly blowing out. Louvered door or ducting, and contractors that is experienced with these should be able to figure those out. Did you want to comment on that?
No, I think we were talking a bit about it in the chat. You're correct. Sorry, breaking up a little bit there. But you do need 700 cubic feet for most models. And there are manufacturer specifications to help inform if a space will require ducting. Some louvered doors or even some gaps underneath certain doors are adequate given the space to get that air intake. So absolutely just assess the situation and go from there.
Great. Let's maybe do a couple more. Somebody was worried about the reliability of heat pump units. He's concerned that he has to replace the unit in 10 years. He'll have a higher carbon footprint than if he had gotten a tankless electric. So any comments on that, Megan, on how these are reliable?
We carry Ream over here at Green Savers, and I think Ream in a lot of ways is becoming kind of the industry standard with these heat pump water heaters. And a big reason for that, in my opinion, is their reliability. I can say I've been doing this over 4 years at Green Savers, and we get very few callbacks on these systems. And with our water supply in Central Oregon, most of Oregon in general, water supply is also very gentle to our storage tank water heaters. So we tend to see them lasting quite a bit longer in Oregon than in other areas of our country. So stand by Ream as a manufacturer. They stand by their products with a robust 10-year whole appliance warranty, and can tell you we do just get very few callbacks or issues with these systems. General Electric's GeoSpring was a little bit of a different beast, but yeah.
Great. Any way to economize on the installation in Corvallis? They've been running $900 to $1,500. Any tips on how to make it more economical, the installation?
So most of what's going to add to the cost is if we need to have anything adjusted or added for an install, such as getting electrical service, a potential sub panel, things like that. So, you know, the way to economize the cost is to have the bones all well set up.
Yeah, the one thing I would jump on that one is because it's, you know, if you think about it, so you have, if you're installing one of these, you get an electrician to come out and do a site visit, then you get the plumber to come out and do a site visit, and then the electrician comes back to do their work and the plumber does their work. So you can see why that can add up. I think it's always, if you're thinking about doing something else, like putting in induction stove, and maybe you need to run a new electrical circuit, or you're putting in EV charger, you know, it's have the electrician come once and get your panel set up for a heat pump water heater at the same time. It can save you a lot of money down the road, because a lot of it's just those guys having to come out and do the visits. So whenever you can gang up these things, you're going to save a little bit of money. But yeah.
And I'll make a comment on that as well. We've only lived in this house for 2 months now, and I kind of have an idea of where I want to end up, but I'm definitely in the process of slowly transitioning things to electric. And so we're doing exactly that strategy, Brian, of as one project comes up, how is this going to move towards our other things going electric, either when we're replacing them or when an opportunity arises, like getting a water heater with the federal tax credit for $100. So because of that, you know, we've been able to plan for that and double up those pieces when we've had an electrician or a plumber out. So then we're ready for it in the next stage.
Perfect. Well, I think we should probably wrap it up. Thanks so much to everyone. We got to a lot of the questions. I just want to let you know that we'll be sending out a YouTube recording of this, and as well as the slides. We've got a lot of requests for those. So we'll be sending those out probably in an email tomorrow to all the registrants here. I want to say thank you a ton to our panelists, Megan Cummings and Neil Baunsgaard, for being with us today. We'll send you information on our upcoming webinars. But if you have any questions, feel free to, I'll send Neil and Megan's contact info as well in our follow-up email, but feel free to reach out to them or to Brian or I. And as we always like to say at the end of our webinars, good luck with all your electrification projects, and let us know where you land. So thank you to everybody.
Thanks, everybody.
Thank you.